You might picture rockets blazing into space or flying through the air when you think of them. What if I told you that one of NASA's most daring rocket designs was intended to take off from the bottom of the ocean? Introducing the Sea Dragon, a massive underwater rocket that has the potential to revolutionize space travel. The Sea Dragon was created in the 1960s to reduce expenses and boost cargo capacity for space missions. Its unusual building approach, which made use of leftover components from the manufacture of submarines, allowed it to be built to its enormous height of 150 meters and 23 meters in diameter. Because of its massive size, the Sea Dragon was designed to be launched from the ocean's surface, where its buoyancy would enable it to rise above the water. It would then launch into orbit with a payload of about 550 metric tons using its powerful engines. To put that into perspective, the SpaceX Falcon Heavy, the most potent rocket currently in use, can only lift a payload of 64 metric tons. The Sea Dragon was a powerful machine, but it was never developed past the drawing board. Due to NASA's shifting objectives and budgetary restrictions, the project was shelved in 1974. But who knows what additional groundbreaking concepts are concealed beneath the seabed? So let's have a look at its history and see where it all started. Robert Trow, a rocket scientist who worked for the U.S. Navy, initially put out the idea for the Sea Dragon in the 1960s. For upcoming space exploration, Trow thought a low-cost, high-capacity rocket was necessary. He suggested the concept of employing a converted submarine as a rocket launch pad. The rocket had a distinctive design in several aspects. First of all, it was created to be launched from the sea. The rocket would be constructed on a barge that would be dragged out to sea. It would then be fired from the ocean when the barge had submerged to a depth of 60 meters or 200 feet. The amount of fuel required to launch the rocket would be less with the underwater launch. The water would act as a cushion, lowering the forces placed on the rocket during takeoff. The Sea Dragon was intended to be a single-stage rocket too. It would transport all of its fuel and engines in one stage, as opposed to the Saturn V, which had numerous stages. This would simplify and increase the reliability of the rocket, lowering the possibility of a launch failure. Finally, the Sea Dragon's fuel would consist of liquid oxygen and hydrogen. These fuels were selected due to their low price and high energy content. One of the most effective rocket fuels is liquid hydrogen, which has a high specific impulse and may produce more thrust per unit of fuel than other fuels. Having some really interesting features, it could also send 1.2 million pounds of payload into low Earth orbit. This exceeded the cargo capacity of the Saturn V rocket by more than 10 times. To carry this out, it had a large fuel tank with a capacity of up to 8.8 million liters. Due to the size of the fuel tank, the rocket had to be erected on top of it before it could be assembled on the barge. The Sea Dragon's 36 engines were positioned in a circle around the rocket's base. The rocket would be able to take off from the ground with the help of these engines' thrust. The turnaround time between launches was shortened by the engine's simple replacement. Finally, the payload bay aboard the Sea Dragon was 29 meters long and 18 meters wide. Its payload bay was big enough to launch huge satellites or whole space stations. But why NASA was considering the plan to launch rockets? Let's have a look at some reasons that NASA had. The infrastructure and launch pads needed to launch rockets from the ground can cost millions or even billions of dollars to build and maintain. The cost of rocket launches might be reduced by using underwater launch sites instead of the expensive infrastructure. Since rocket explosions or other problems can have disastrous results, launching rockets from the ground has inherent safety hazards. So, using underwater launchers to fire rockets offers a natural safeguard that can reduce these dangers. The surrounding water would cushion the shock and lessen the damage to adjacent buildings or people if an underwater rocket were to detonate. Moreover, underwater rocket launches offer a degree of stealth and secrecy that is unattainable with terrestrial launches. For military or intelligence tasks, when the element of surprise is essential, this may be helpful. And last, launching rockets from underwater offers more location versatility. While submarine launches may happen from almost any place with deep enough water, ground-based launch facilities are restricted to particular geographic areas. The U.S. Navy took on this project which was expected to transform the space race with its cutting-edge capabilities. The Sea Dragon, however, had several difficulties that ultimately contributed to its failure. Funding was one of the biggest problems encountered throughout the project. The estimated cost was reported to be around $500 million, which was a sizable sum of money in the late 1960s. And there was little interest in devoting extra funds to the Sea Dragon because the US government had already invested substantially in the Apollo program. This significant budget gap prevented the project from moving past it. Another challenge that the project was unable to overcome was the rocket's complexity, which made it challenging for engineers to design and build the rocket. The rocket was intended to be gigantic, measuring 23 meters in diameter and more than 150 meters in height. This made it far bigger than any other rocket available at the time, and creating such a massive vehicle presented several engineering difficulties. The rocket's architecture was also unusual, with a particular fueling mechanism that called for specialized infrastructure. The concept piqued the interest of the Navy as a way to put military payloads into space. However, other branches of the military, including the Air Force, were skeptical of the rocket's capabilities and saw it as a threat to their own rocket programs. This lack of support from the military was another significant obstacle that the project could not overcome. Even though the Sea Dragon project was never completed, it had a lasting impact on the area of rocket engineering and served as an inspiration for other initiatives. The sheer size of the Sea Dragon project is one of the main reasons it is still remembered today. It would have been 3 times bigger than the Saturn V rocket, which was utilized in the Apollo missions to launch people to the moon. A cargo of 550 metric tons, or about the weight of 50 school buses, might have been launched into low Earth orbit by the Sea Dragon. Some ongoing efforts and advancements in the area of rocket engineering might be considered as the Sea Dragon project's legacy. One example is the SpaceX Starship, which is presently under construction and has objectives comparable to those of the Sea Dragon project. The Starship, like the Sea Dragon, is intended to be completely reusable and capable of carrying enormous cargo into space. Elon Musk, the CEO of SpaceX, has even said that the Starship would eventually be capable of launching up to 100 metric tons of cargo into space, which is less than the Sea Dragon but still a sizable quantity. The SLS rocket, which NASA is presently developing, is another project that was inspired by the Sea Dragon. The Orion spacecraft, which will eventually transport people back to the moon, may be launched using the SLS, which is intended to be the most potent rocket ever built. Although not completely reusable like the Sea Dragon or the Starship, the SLS was nonetheless created with dependability and efficiency in mind. The Sea Dragon project has influenced the private spaceflight industry as well. To lower the cost and increase the accessibility of space travel, many private businesses are now constructing their own rockets and spacecraft. One such company is Blue Origin, run by Jeff Bezos, the creator of Amazon. The new Glenn rocket, which Blue Origin is constructing, is intended to be totally reusable and capable of carrying payloads into space at a cheaper cost than current rockets. The Sea Dragon never got off the ground, and it remains a fascinating footnote in the history of space exploration. There are a lot of promising opportunities for space research in the future, such as the creation of reusable rockets, space travel, and business endeavors in space. As we continue to push the limits of human exploration and discovery, the lessons learned from the Sea Dragon project will guide these future initiatives. And that's all for today, folks. Thank you for watching. We will see you soon with more interesting videos.